This is Preeti Leela from First EC from Dr. Umaya Ramanathan College for Women, Karaikudi. Today, my purpose here is to teach you a topic called Laws of Transverse Vibration of String from Unit 1, Waves, Oscillations and Ultrasonics. Before going into the topic, we should know about types of vibrations. There are three types of vibrations. They are longitudinal vibrations, transverse vibration and torsional vibration. Longitudinal vibration. When the particle of a bar or disc move parallel to the axis of shaft, then it is called longitudinal vibration. Transverse vibration. Vibration in which the element moves to and fro in a direction perpendicular to the direction of the advance of the wave. Torsional vibration. Torsional vibration is the angular vibration of an object, commonly a shaft, along its axis of rotation. Laws of transverse vibration of string. Before going into this topic, we should know about an important formula. Frequency of vibration N is equals to 1 by 2L root of T by M, where L stands for length of string, T stands for tension and finally M stands for linear density. There are three laws of transverse vibration of string. Let us know about these. First law, law of length. The frequency of vibration of a stretched string varies inversely as its resonating length. It happens when T and M are constants. N is directly proportional to 1 by L, whereas N is inversely proportional to L. Example for first law is guitar. Because when we operate, that is when length decreases, frequency increases. When we doesn't operate the guitar, that is when length increases, its frequency decreases. Second law, law of tension. The frequency of vibration of a stretched string varies directly as the square root of its tension. It happens when L and M are constant. N is directly proportional to root T. For example, for second law is guitar. Guitar has screw. So, when we increase the tension in the screw, frequency also increases. When we doesn't increases tension in the screw, that is when we decrease the tension in the screw, frequency also decreases. Third law, law of linear density. The fundamental frequency of vibrations of a string is inversely proportional to the square root of mass per unit length. It happens when L and T are constant. N is directly proportional to 1 by root M, whereas N is inversely proportional to root M. Example for third law is guitar. Guitar has 6 strings with different density. When we operate the string with higher density, its frequency decreases. Similarly, when we operate the string with lower density, its frequency increases. Thank you. Hi, this is Preeti Leela from First EC from Dr. Umaya Ramanathan College for Women, Karaikudi. Today, my purpose here is to teach you a topic called Energy Stored in a Stretched Wire from Unit 2, Properties of Matter. Energy stored in a stretched wire. Original length of the wire is capital L. Area of the wire is A. Stretched or increased length of the wire is small l. From the modulus of elasticity, we know Y is equals to stress by strain. Formula for stress is force by area. Similarly, formula for strain is stretched length by original length. So, finally we get Y is equals to FL by LA. So, F is equals to YA small l by capital L. If the wire is stretched by small length, that is dx, and a small arc is done on the wire, then work is equals to force into displacement. We should integrate both sides. We get Integration of dw is equals to integration of f into dx. We have already found f in last step. F is equals to yal by L. We should substitute here. That is w is equals to integration yal by L dx. Here y, a and capital L, that is original length of the wire, are constant. So we should only integrate L. After integrating, we will get W is equals to YA by capital L into small l square by 2. W is equals to half YA small l by capital L into L. We know YA small l by capital L is equals to F. So W is equals to half F into small l. That is W is equals to half stretched force by stretched length. Next is to find energy density. Formula for energy density is work by volume. Volume is equals to area into length. So energy density is equals to half F into small l whole divided by A into capital L. So energy density is equals to 1 by 2 F by A small l by capital L. Finally, energy density becomes half stress into strain. This is energy stored in a stretched wire. Thank you. Hi, this is Preetaleela from 1st EC from Dr. Umayal Ramanathan, College for Women, Karaikuri. Laws of thermodynamics. There are 4 laws of thermodynamics. They are 0th law, 1st law, 2nd law and 3rd law. 0th law states about temperature, 1st law states about internal energy, 2nd law states about entropy, 3rd law states about absolute zero. 0th law. 0th law states that if two bodies are in equilibrium with the third body separately, then its two bodies are also be in thermal equilibrium with each other. First law of thermodynamics. It states that energy can be converted from one form to another with the interaction of heat, work and internal energy. But it cannot be created nor destroyed under a circumstance. Formula for first law is total internal energy, which is equals to heat change between system and surrounding plus work done by the system or on the system. Mathematically, it can be denoted as del U is equals to Q plus W. Second law, Kelvin, Planck statement, Clausius statement. First, we go through Kelvin, Planck statement. There cannot be heat engine which is working with single turbine reservoir and producing work. Clausius statement. You cannot have a heat pump in which the heat is transferred from low temperature body to high temperature body without investing work from outside. Overall, second law states that if two bodies are kept at different temperature, then the heat will transfer from one body to another. Third law. Third law of thermodynamics states that entropy of a perfect crystal at temperature of 0 Kelvin is 0. The given diagram is a perfect crystal. Third law states that perfect crystal at room temperature of 0 Kelvin. 0 Kelvin, which is equals to minus 273.15 degree Celsius, is 0. Thank you.
Electricity and magnetism. The agendas are topics: potentiometer, principle, measurement of thermo EMF using potentiometer, magnetic field due to a current carrying conductor, Biot-Savart law, power factor, types of switches. Next we have to see potentiometer. Potentiometer. A potentiometer is defined as a three-terminal variable resistor in which the resistor is manually varied to control the flow of electricity. The principle of potentiometer is the potential drops across any section of wire will be directly proportional to the length of the wire. Next, we have to see measurement of thermo EMF using potentiometer. If two junctions of the thermocouple are maintained at different temperature, then thermo EMF is developed between them. It can be maintained by balancing it against the potential drop across a length I. Next, we have to see magnetic field due to the current carrying conductor. The magnetic field produced due to a current carrying conductor has the following characteristic. The conductor, it lies in a plane perpendicular to the conductor. Reversal in the current flow reverse the field direction. Next, we have to see Biot-Savart law. Biot-Savart law states that the magnetic field due to a current carrying conductor at a distance point is inversely proportional to the square of the distance between the conductor and point. And the magnetic field is directly proportional to the length of the conductor current flowing in the conductor. Next, power factor. Power factor is the expression of energy efficiency. It is usually expressed as percentage, and lowest percentage, the less efficiency power used is. Power factor is the ratio of working power measured in kilowatts to ampere power measured in kilowatt. Next, we have to see types of switches. Switches: network switch, push button switch, pressure switch, limit switch, and etc. The switches are in many types. We have to see etc. that are. Thank you. I am Vishali from First EC department. Thank you.
Hi friends, I am E. Suchita. First BSc EC. Today topic is De Morgan's theorem. There are two theorems of De Morgan's. De Morgan's first theorem formula A plus B whole bar equal to A bar B bar. De Morgan's second theorem formula AB whole bar equal to A bar plus B bar. Next, De Morgan's first theorem theory. The complement of the sum is equal to the product of the complement. Next, diagram. Two inputs, one outputs. Gate use AND gate 1, NOT gate 2. Second diagram. Two NOT gate, one OR gate. Two input, one outputs. Next, De Morgan's theorem second theory. The complement of the product is equal to the sum of the complement. Diagram. We use gate 2, one AND gate and one NOT gate. Two inputs, one output. Second diagram. We use two NOT gate, one OR gate. Two inputs, one output. Truth table. First theorem. A 0, B 0, A bar 1, B bar 1, A plus B 0, A plus B whole bar 1, A bar dot B bar 1. Next, A 0, B 1, A bar 1, B bar 0, A plus B 1, A plus B whole bar 0, A bar dot B bar 0. Next, A 1, B 0, A bar 0, B bar 1, A plus B 1, A plus B whole bar 0, A bar dot B bar 0. Next, A 1, B 1, A bar 0, B bar 0, A plus B 1, A plus B whole bar 0, A bar dot B bar 0. Truth table. Second theorem. A 0, B 0, A bar 1, B bar 1, A dot B 0, A dot B whole bar 1, A bar plus B bar 1. Next, A 0, B 1, A bar 1, B bar 0, A dot B 0, A dot B whole bar 1, A bar plus B bar 1. Next, A 1, B 0, A bar 1, B bar 0, A dot B 0, A dot B whole bar 1, A bar plus B bar 1, next A 1, B 1, A bar 0, B bar 0, next A dot B 1, A dot B whole bar 0, A bar plus B bar 0,